Hi everyone, welcome to another lecture in the mathematical methods course. Alright, I hope you all are doing well, and I hope you remember that in the previous lecture we talked a bit more about probability distributions, we talked about the median, the mode, and I feel like some of you may be wondering, what about the mean? You know, how it goes, mean, median, mode. What about mean? We haven't discussed that yet. And that's what we are going to focus on for this lecture mainly, and one other thing that we are going to learn soon enough. But before we do that, we're going to start off with a simple experiment, okay? So let's say you have a fair dice, okay? A normal standard dice, and you roll it 120 times, okay? So you have a dice, you're rolling it 120 times, okay? How many sixes do we expect? Okay. So, can you just really quickly think about it, give it a try. Just think about how many sixes do we expect? And we're going to talk about it later. All right, so hopefully you paused and you gave it a try. Okay, so let's just think a bit about it and we'll figure something out. Okay, so the probability of getting a 6 on a roll, okay, is 1 on 6, okay, because it's a fair dice, there's no cheating going on. All right, so the probability of getting a 6 is 1 on 6. Therefore, out of 120, right, 1 on 6 would be a 6, okay? Right, that makes sense. Because there's a 1 in 6 chance of getting a 6, out of 120, 1/6 of them would be 6s, okay? That's a pretty intuitive way. So we expect 120 times 1 on 6 is equal to 20. So we expect 1/6 of them to be 6s. So we expect 26s in total. Now, it is important to note that we expect that, okay? Because that very much does not mean that we will get 26s, okay? That doesn't necessarily have to happen, but that's how much we expect, okay? Not expect, all right? So, important to emphasize that and recognize that whenever we are working with anything like this. But it's not that we can just look at 6s. We can take this whole ideology to an entire experiment, to an entire probability distribution. Okay, so for example, if we consider a spinner, okay, so we have a spinner like this, and we have the values 2, 2, 4, and 1. Okay, it's a bit unconventional maybe, but this is what we're working with, all right? So, when we roll, or when we spin the spinner, what do we expect? What value do we expect? Okay? Now, think about that one and let me know what, think about it, try and write it down, pause the video, okay? And just see how you go with it, and we'll discuss it later. All right, so we're back, and let's think about this. Now, some of you may have thought that you would expect a 2 because it's the most likely outcome, all right? So that's a fair way to think about it, but that's not quite what we expect, okay? That is the mode, that is the most likely outcome, but it's not what we are expecting. The way we find the expected value is we use this sort of thinking where we go, okay, there's a 1 in 4 chance of getting a 1. There's a 1 in 2 chance of getting a 2. And there's a 1 in 4 chance of getting a 4. Okay? And then you add up all of that, okay? You add up all of that, you get 1 on 4 plus 1 plus 1, which is 9 on 4, I believe. All right. And this is now your expected value. Okay? Not 2, not 4, not 1. It's actually something that isn't even on the spinner. Okay? That is an interesting thing because that doesn't happen with the mode or the median. Okay, they're always one of the possible outcomes. This is just a completely different thing. And the way to think about an expected value is not something that you get. It's not like one of the possible options. It's more like if you keep doing this experiment, okay, that's how you actually define an expected value. If you keep doing this experiment again and again and again, then in the long run, okay, the average or the mean value, the average of the outcomes will be 2.25. Okay, that is what an expected value means. This is a very important, and it's kind of like you use it every time you think about an expected value. You have to remember this definition, that in the long run, the average outcomes will be 2.25. By long run, we mean we keep doing this experiment a very, very large number of times, and the average of all of those values would tend towards 2.25. Okay, that is what we are saying. All right. And now you would say, well, I know how to calculate it for this one, and maybe you even know how to calculate it anywhere, but let's just define the formula, and then you are sure you can find it anywhere. Okay? So the formula is E of x, the expected value of x, or mu. Okay, that's also how we notate it. Both of them completely fine. But in the exam, from personal experience, you see mu more often than E of x. Okay, so mu is equal to the sum of, I equals 1, not x. Sum of I equals 1 to n of xi and pi. What that means is the sum of every outcome multiplied by its probability. Okay, if you notice, that's what we did here. Our outcomes are 1, 2, and 4, and the probabilities, 1 over 4, 1 over 2, 1 over 4. We multiplied those, and then we added all of that like this. We summed it, okay, and we figured that out, figured the expected value out. And this is really just all you have to do when you do this, okay? It's not a very hard process. It's rather simple and pretty much straightforward, okay? So, given that, we're going to look at one more thing that I mentioned earlier. The second thing we're going to look at. It is called the variance or the standard deviation, okay? Before we get into that, I would like to tell you that stats is not like calculus in the way that you have to just kind of know stuff and apply it. Like, it's mainly using formulas and just understanding where to use the formulas. So most of what I teach here should really just go on your cheat sheet, and from there, it's from cheat sheet to paper. Okay, that's mainly all you need to do for stats, but you just need to practice and understand where what formula applies. So knowing what is happening and is all that's required. After that, it's just putting stuff into a formula. The other thing, very heavily relied on a calculator. So maybe not now, maybe you see that later onwards, most of it is done on a calculator. So again, cheat sheet stuff, just knowing what you're doing, and that is how this topic works. Now, on to standard deviation. Okay. Variance and standard deviation. I'll write it out once and then I'll just write it with the acronym. standard deviation. Okay, so variance or standard deviation basically mean, well, you have your expected value or your mean. Okay, they basically say that when you do this experiment, sometimes how much are the values you get going to differ, or how far away are they going to be from your mean? Okay, that is basically how they tell you. Like, if you get this as your mean, how much is the spread away from the mean? Like, how far away are the actual values you get from the mean? That is basically what they tell you. So if you have, for example, a machine that creates some sort of object that needs to be accurate to a certain measurement, okay? The standard deviation, if it's large, or if the variance is very big, that would mean that the object that is created has a very big range of measurements, okay? That some may be very close, but mostly very far away from the required measurement. So that is a bad thing. The standard deviation is small, all of the values are close to the measurement, so we are doing the good job. Better, more amount of times, okay? So that is just what it means. How far is the spread, okay? So we're just gonna look at the formulas, and really it's not that intuitive to come up with them. So like I said, this just goes on your cheat sheet, but I will explain what is going on in just a second. So this is your variance, okay? This is not 6, it is a small sigma, okay? So, what else? All right, so that is notated as a square. You'll see why later. But yeah, so your variance is equal to the sum of, I should probably do that again. Okay, this is equal to the sum of your outcome, take the mean, okay, so obviously how far it is from the outcome, you square that, and then times it by the probability, okay? And then your standard deviation is just that, but underneath a square root, okay? Your standard deviation is literally the square root of the variance, okay? So it's all of that same stuff, okay? You can see why they would use a square, mainly over here, okay? They use a square because, you know, there would be some values that are below the mean, some values that are above the mean. If you don't use a square, what would happen is that you would get some negative differences, some positive differences, and they would tend to cancel out, okay? Which would not give you an accurate estimate. That is why you square it, okay? To get the absolute just distance between the points, and then from there on onwards, you just sum the points and the probability of getting that difference and all of that, okay? So if you really want to look at it, it can feel a bit intuitive, but you don't have to. Just understand the formula, where what value is where, okay? And if you think that this formula is a bit complicated, then there is another one, okay, which you may want to use more often than the other one. It is this one. Okay, so it is outcome squared times the probability of the outcome times the mean, take the mean all squared, okay? That is another way of finding the variance, and then hence also the standard deviation, the square root, okay? So that is all there is for the mean and the standard deviation, and it's really a stepping stone for bigger and more different variables, okay? So it's very important to be able to practice this very quickly and effectively and put it into action easily. So do practice that, and yeah, just meet you in the next one.